Should I start, Jim, sharing my screen? Or not yet?
Not yet.
Okay.
We'll give that a second. I'm going to do some introductions. Good morning, everybody.
Morning, Jim.
Yeah, we're just going to. I'll do that in a couple of minutes because I still got 9:56. We've got a full class here, so I feel like we're going to have a lot of people popping on. Want to make sure we give people a couple of minutes to do so.
Sure.
So we'll go from there.
How's the weather by you, Jim, today? Cold, I guess.
Yeah, not too bad. I did a camera demonstration this morning, up north of here a little bit, but wasn't too bad.
Do you have was it a router or do you have the FlexiTrack?
I have the FlexiTrack.
Oh, okay.
So.
Is that the one you demoed this morning?
No. I did the push rod.
Oh, the push rod. Okay.
Yeah.
Boy, that's they did a nice job with that new controller.
Yeah, they did. One thing I did note, the push rod that we have, well, the one that the customer had mentioned, the push rod doesn't show the pitch of the camera.
No.
Whereas other cameras that they've used do. So I asked Keith about that because there's a actual degrees at the bottom right of it, and I was wondering what that was for. That turns out that's the pitch of the image on the screen. So,
right.
Yeah. Not a big deal, but this particular customer thought it was interesting.
For the bigger guns have the pitch, like the FlexiTrack.
Yeah, that does, right.
The crawler gives you the pitch. On a push rod camera, it's difficult because it's a push rod. So the push rod could be, in the camera head could be in any position. So I don't know.
Right.
Yeah.
All righty, folks. I got 9:58. We'll give it a few more minutes because again, like I said, we're going to have quite a group here today. This class did fill up, which is great to see. Glad everybody can take their time out before we go over a couple of instructions. We do an introduction for Gus. Alrighty, I've got 10:01 a.m. and we'll probably have some people obviously jumping in on this meeting here in the next couple of minutes. Gus, are you ready?
Yes.
Okay. Well, welcome everybody. Good morning. Thank you for joining us with Eastcom Associates. My name is Jim Flint. I am the upstate New York representative for Eastcom. We have several of our fellow staff here with us today. We have Eric Denslow out of the New England area, and also Gus Salas. Gus is going to be doing the presentation for us. He's out of our New Jersey office, so he's going to be doing that presentation for us today. Just a little bit of housekeeping here. What we'd like to make sure you do, please keep yourself muted during the presentation. If you do have a question throughout the presentation, what you can do is you can either raise your hand. You do that by, if you go down at the bottom here and you click chat, in the bottom right, you'll see a raise your hand option. Some people have also said they found it in the reactions tab. When you go to the bottom of your screen, there's a reactions there too. I don't see that on my version, but some people have said that it is there. So look in both places for the raise your hand option. I'll be monitoring this presentation for those hands. So when I see those go up, I'll call on you and then you can unmute yourself and ask your question, because we don't want to skip over anything on you. Alternately, what we can do is you can also type in the chat to everyone your question, and I'll be monitoring that as well, and then I'll stop the presentation at a good point and we'll answer that question for you. Presentation should take about an hour or so, you think, Gus?
I think it'll be a little less than an hour,
Okay.
so I hope to have the possibility of answer any questions.
Great.
That anyone might have.
Okay, and this is just our next class in a series of classes that we do throughout the winter months here to make sure we get some good information on underground utility protection out to you, the stakeholders in damage prevention. So, and again, we're always here for questions like this to help you in all your needs for that. Okay, Gus, if you are ready, I'm going to go ahead and hand it over to you.
All right, thank you.
We'll
start. Okay, here we go with the, can you all see the first slide, Jim?
Yes, we can.
Okay, good. So we're going to start with this. Okay, so good morning, everybody. My name is Gus Salas. I'm with Eastcom Associates. Jim and I and Eric and Mark that I see out on the call, we all work together. This class is going to take about 45 minutes. Try to keep it, within those time constraints. So our company, Eastcom Associates, this is a little bit of an advert. This is what we do. We sell equipment, locating devices like you see here, equipment to locate valve boxes, valve covers, manholes, electronic markers and marker locators. I will cover a little bit of this technology as part of this presentation. Ground penetrating radar. Here you see a variety of models of ground penetrating radar. This will be also part of this webinar. Other equipment, detectable routers, such as the Jameson Duck Hunter series that you see here on the left, some other equipment that we sell. Soft digging, vacuum excavation equipment. You see the AirVac made by Guard Air, the Aerospace. These are tools for excavating near buried utilities. So this is what we do. This is what our company does. Okay, now for locating non-metallic lines, what is out there? Most of you, I'm going to assume, are familiar with electromagnetic tools, such as pipe and cable locators, ground penetrating radar, ferromagnetic locators, wands. These are tools. All of these fall under what are called electromagnetic tools. Pipe and cable locators, very simply, I'm not going to dwell too much on this because this is not the purpose of their presentation, but Pipe and cable locators basically locate underground currents, okay? Where do those currents come from? Well, you have a device called a transmitter that allows you to inject your signal into the a target line that you want to locate. Think of this as a battery. That's one crude way to inject the signal. Another one is to simply drop the box. So once you get that signal traveling, for the signal to travel on a regular locator, you have to have a conductive means. In this case, could be a pipe, and the signal travels along the pipe because it is metallic, okay? And then once you get the signal going, you can locate that line and we're all nice and good. What happens when the line that you need to locate is non-metallic? Well, that signal from the locator is not going to travel along that line. What happens if the line is full of water? You know, we all think water is a conductor. You know, if you have you're barefooted and your foot are wet, don't touch the electrical outlet. It's gonna, you know, you're conductive because there's water. Well, really, for all practical purposes, water is not a great conductor. Okay, it conducts a little bit. It is certainly better than dry sand, but for what we need, when we locate a better utility, water doesn't carry the signal long enough to be meaningful. So if you have a plastic water pipe full of water, the signal is not going to travel far enough. It may travel 3-4 feet and then dissipate, which is useless. You know, we don't need to locate 4 feet. We need to locate 400 feet. So what else do we have? What we're going to cover today are the technologies that are available for locating non-metallic lines. There's not one that is 100%. So many times it's a combination of these things that will get you the answer that you're looking for. So what are these tools? Well, you have detectable rods and sondes, and we'll describe what these things are, electronic markers, the pressure wave method, and ground penetrating radar. So let's start with a detectable radar. What is a detectable radar? Here you see a person inserting that flexible rod into, it could be a drain line or it could be a duct. These detectable radars come in different sizes. Okay, here you see a small size. I do happen to have one sitting behind me, the yellow reel that you see, that's a little one. They come in different diameters, the smallest one being 1/8 of an inch, the largest one being here on the right, 7/16, almost half an inch in diameter. Different diameters have different rigidities, meaning that they can go farther. Here you see what a detectable radar looks like. That is about 2.5 foot tall, okay? Now that rod is really a jacket with a core, which is fiberglass, and inside that fiberglass, there's a copper wire embedded inside the rod. And that wire is what you locate when you're locating the rod. So let's say that you need to locate a gas line, okay? A gas mains, which is plastic and where there's no tracer wire. This is like bringing your own tracer wire to do the locate. You insert the rod into the line. In this case, you see this apparatus that the field technician is inserting the rod into. This device allows you to access the gas mains in a live situation, meaning that you do not have to shut off the gas supply to insert the rod. This is called an insertion device. Needless to say, there are very few people that can do this within the gas company, and you have to be either the gas company or a contractor doing work for the gas company to be able to do this, because you're inserting that rudder into a live gas mains or into a live gas service line. So this insertion device allows you to insert this rudder for as long as you need, and they come up to 1,200 feet long, so that from a single insertion point, you can do 1,200 feet in one direction, 1,200 feet in the other direction. Once you have the rod inside the line, it's like having your own portable tracer wire. You can locate that rod, you can locate that wire, mark it, and done, end of the job. Here you see a little bit of a closer detail. You see the red alligator clip clipped to that brass knob on the side of the cage. That brass knob gives you access to the wire that is embedded inside the rod. Then you ground the other side of the transmitter, and now you've energized the length of the rod that you need to locate. Okay, here's another point of injection for the signal on a different rod. This is a little bit of a larger diameter. It's a 5/16. Again, you make your connection, you clip your alligator clip to here, you ground the other, the black alligator clip of the transmitter, and now you're energizing that rod. Okay, here you see the setup. So once it's in the line that you need to locate, for example, here we're showing a drain line. You insert it into the line, you ground your transmitter, and you go out and locate. Now, in the same way as when you locate a tracer wire, you do need to have a minimum length of rod inserted into the line that you want to locate for it to be effective. You need distance. You know, same as with a dragster, you gotta have a minimum distance to develop speed. The rod, the signal requires a minimum distance to be able to travel. So short distance is not gonna travel. If you insert only 5 feet or 10 feet, it's not enough. You need more rod inside that conduit or inside that line for the signal to be able to get some legs, okay? So once you have some distance, and we normally say push as much as you can into that line without certain limits. You know, if you can get 50 feet, good. If you can get 100 feet, even better. And then you go out and locate it as you would locate a tracer wire. Now, that signal is going to drop normally, as it does with any other locate. The further away you walk from the transmitter, the weaker the signal becomes, all right? Towards the end of that rod, and to the right of the image here, you see the end of the rod where that vertical dotted red line is. Towards the end of that rod, that signal is going to rapidly decay, and you will get to a point where the signal is completely gone past the end of that rod. Okay, so you can't really tell where it exactly ends, but you can approximate it, I would say, within plus or minus 10 feet, you'll be able to tell, hey, I got good signal here, and you walk another 10 feet and the signal is completely gone. So what some people do is they will halve that distance and they say that that is the end of the rod, okay? So this is the way that the signal coming off a detectable rod decays as you walk away from the source, okay? Now, what I show here are inspection cameras, push rod inspection cameras used by municipalities, used by plumbers, by contractors to inspect ducts, to inspect sewer lines and drain lines. Most inspection cameras today have a built-in beacon or sound that will emit a signal that you can pick up from the surface. I will show you this a little bit later. But also, these cameras can be, the rod that you're pushing the camera with can be located in a similar way because these rods have wires in them. So if you can get the signal onto one of those wires, then you can locate the entire length of the rod as you would locate with a detectable rod that I showed you some moments ago. Here I show you for the particular case of the FlexiProbe cameras, which are cameras made by a company called Pairpoint, which we happen to sell. This point, the connector itself that connects you to the monitor is a great point to inject the signal. And here I show you the red alligator clip around the outside of the connector. So those rods that go from here all the way to the tip of the camera have actually wires in them. So when you're connecting to the outside, you're actually connecting indirectly to the ground of that rod, and you're able to send signal all the way out. For other camera manufacturers, this is you gotta try and see what works best. We know that for the PurePoint camera, this point of injection works great. For other cameras, you might find other points of injection. All cameras have a bunch of wires going from the reel all the way to the tip of the camera. So one way or another, you got to find out how to inject that signal. This is not going to interfere with the video. This is not going to burn anything out. The signal that we're talking about here is a very weak radio frequency signal of the same type that you tune to with your AM or FM radio in your trucks, your cars, or at home. Okay, it's a radio signal. It is very weak. It's not going to damage anything. So this is inspection cameras. Okay, now what else can you use other than rods to locate non-metallic lines underground? Well, there is such an accessory called a sonde. Sondes are beacons. They come in different sizes. To give you an idea of the size, we superimpose here a can of Coke, so that you get an idea of, that's a 16-ounce can of Coke. So you get an idea of the size of these things. Some of them are very small. The one at the bottom is about half the diameter of your pinky. And the one here, the big one, almost all the way to the top, called the super sonde, that is about two and a half cans of Coke on end, okay? Why do they come in different diameters? Well, different people have different needs. The one at the bottom is made to locate inner duct. So those are the ducts that are inserted into a 4-inch duct to hold fiber, okay? The one at the top, called the super sonde, all the way to almost next to the top, the super sonde is a 2.5-inch in diameter. I think it's about maybe a foot long, has a depth range of 50 feet and a frequency of 33 kilohertz. So that is a deep sewer line locating device, okay? And then you have all the other ones in between. The one in the center, that's the most popular one, called the standard sonde. Comes into two frequencies, 512 and 33. Why are we talking frequencies here? Well, we're talking frequencies because different frequencies work in different materials. For example, if you need to locate cast iron, a cast iron sewer line, 512 hertz, which is a very low frequency, is going to be the one that will be able to somewhat penetrate through the cast iron. If you're talking steel pipe, no sonde is going to go through steel. But then if it's a steel pipe, you don't need a sonde because you can locate the pipe. What about terracotta or PVC or cement? Well, you can use any frequency in cement. You could use 512. You could use 33 kilohertz, which is 33,000 hertz. So we're going from 512 hertz to 33,000 hertz. 33,000 hertz is going to give you a little bit more reliable signal than 512, and it'll be less prone to interference by nearby power lines that you might have. Okay, so there are different frequencies for different sondes. Normally, inspection cameras come standardized with 512. Some of the more complete or more sophisticated systems allow you to set the camera frequency between 512, 8, and 33 kilohertz. But a sonde is a device that you can locate from the surface. Here you see another view of the different variety of sondes. This is you see next to the quarter and to the penny, you have a very little sonde next to the big super sonde, okay? All these sondes work with batteries. The one that you see on the photo uses a AA, which is the one that I happen to be holding in my hand right now. This is a a sonde with I think it's a 10-foot nominal depth range, and the diameter is just under 1 inch. And again, different needs, different sondes. When you locate the sonde, you're locating just the sonde. You're not locating the entire rod, you're locating just the sonde, just that beacon. So it's a point in the ground, all right? Very useful for locating blockages in conduits. If you're inspecting a sewer and you see something that needs to be addressed, you know, a breakage in the line or infiltration, then you turn on the sonde on that camera and you locate that point, you put an X on the ground, and now the contractor that will be fixing this knows where to excavate. Okay, so when you locate the sonde, you're locating a point on the ground. I've seen some crude and rudimentary things done with sondes to locate, for example, big sewer lines with a lot of flow. So you open the manhole, get 2 bottles of Coke, you cap them well, put some duct tape, and you're creating a floating device. You can put the sonde on that and let it float away with a string, and you locate as you go. Here you see the sonde emitting the signal and how you locate it from the surface. There's a little bit of an animation here because when you locate the sonde, you really locate 3 peaks. And you see the 3 mountains here. So you locate in one direction first, and you locate across. And what you really are looking for is that top peak, which is flanked by 2 smaller peaks, one in front and the other one behind. It is important to locate all 3 when you're locating a sonde, because if you stop at the first peak, let's say you stop at the one that is in front, the distance, the separation between these peaks is related to the depth. So here you see between points A and B is 7/10 of the depth. I'm sorry, the depth is 7/10 of the distance between the 2. Roughly speaking, each peak will be separated by a distance approximately equal to the depth. So if you're looking at a line that is 10 feet deep and you locate, say, the front peak, which is called the ghost signal, that will be approximately 10 feet off where the sonde actually is. So if you're a digging contractor and somebody told you to dig and you're 10 feet away from where you actually needed to dig, not good. So that's why we say it is very important that you locate all 3 peaks, and the one in the center, which will be much stronger signal, that's where the sonde is, okay? Again, sondes are accessories to your locating device and will be very handy to mark spots on the ground. Here you see a sonde attached to an inspection camera, okay? When you locate the sonde, again, you're locating the camera. You're locating that point. You're not locating the line. Here you see an example of 2 crawlers. And in these particular crawlers, they have a sonde built in. In this particular brand, which happens to be a Pairpoint, the sonde is here towards the back of the crawler. So when you're locating that sonde, you're about a foot away from where the camera head actually is, okay? That may be important or not. Just keep in mind that you're locating the back of that crawler. All right, so what else do we have to locate underground lines? There's another method that's been around since, as I understand, 1992, called the pressure wave. This is for locating non-metallic water and nothing else. And here you see the components that are part of this pressure wave system. Here you see a photo of the receiver, which is a long stick with a probe at the bottom. What you see on the right are 3 transons. These are mechanical transons, and there's also an electronic transons. The pressure wave method is relatively simple to understand. It consists of using the water and the water pressure. That's why it requires that the pipe be pressurized. Minimum pressure required is 15 pounds. Maximum is 100 pounds. Okay, so there are 2 limitations. And you attach the transon to the water system. Here it is directly attached, in this case, to a spigot. Obviously, it needs to have a screw. The system comes with adapters, but basically that mechanical valve has a spring and a T-handle that you regulate, and you regulate it until that valve starts to vibrate. It starts to open and close very quickly, okay? Once a second, twice a second, 3 times a second. That vibration, that opening and closing of the valve, what it creates is a mechanical wave that travels back along the pipe, all right, that feeds water to that spot. So that mechanical vibration that travels along the water makes the water vibrate, makes the wall of the pipe vibrate, and makes the ground around the pipe vibrate. We're talking here a small vibration. It is not nothing substantial. And here you see the system applied to another underground point. And this happens to be the electronic transon, where it is not mechanical, where you don't have a spring opening and closing that valve, but you have a solenoid valve that is controlled by this blue box. The effect is the same. The blue box will signal the solenoid valve to open and close so many times a second, with the purpose of creating a small vibration, a small controlled vibration that travels back along the water. So let me show you a little bit of a video. This is a short video that is going to, if you can listen, you will hear a click. That click, and you see the red LED coming on and off. Every time you hear that click, that is the solenoid valve opening and closing. Every time it opens and closes, it squirts a little bit of water out. You can see the water squirting on the lower right of the image here of the video. Okay, so that water squirting out, what it does, it creates a pressure wave that travels back. Okay, for those of you that are in the water industry, think of this as a controlled water hammer. It is not water hammer, because water hammer is bad and it is strong. This is very weak, but it is vibration, all right? The wall of the pipe vibrates, the ground around it vibrates, and then you walk out with a sensor such as the one shown in these 2 images. It's we'll call the RD500 receiver. At the bottom has a seismic sensor with a spike, or in the case of a hard surface, you put the brass plate. And basically this seismic sensor is picking up those waves as they travel through the ground, all right? Then you're going to place the probe on the ground and listen for that vibration. The idea is that the closer you get with your receiver to the source of the vibration, which is the water inside the pipe, the stronger that signal will become. You see here low signal, medium signal, high signal, and you can both hear it and see it on the display. Now, this all works great on paper. In the actual world, things could be a lot different. I've used this device for many years. Our company doesn't provide service. When I say that I've used it, I've used it in demonstrations and I've used it in training sessions. In the South, say Texas or Louisiana or Florida or California, it works very well. Why is that? Well, pipes are not that deep. Here in the Northeast, our pipes are going to be anywhere from 3 to 5 to 6 feet deep. And if you go to Florida, they don't need to be that deep. They don't have a frost line. Okay, so there may be a couple of feet underground, maybe 1.5 feet, no big deal. So that signal is going to be more readily detected when the pipe is shallower. Here in the Northeast, with deeper pipes, the signal has a difficult time getting from the pipe to the surface. And so how can you, is there a way to compensate for that? Yes, you can compensate for that by injecting a stronger signal into the pipe. But if you remember a few moments ago, I spoke about water hammer. Well, a stronger signal is starting to resemble water hammer. What does water hammer do? It'll break the pipe. If you're dealing with old infrastructure, like probably most of you have in your areas, well, that old infrastructure is not going to stand the pressure wave, the stronger pressure wave that you may need to be able to locate it. So, it is always a balance. How badly do you need to locate versus how badly are you able to withstand damaging the pipe? And so, it is always it's always a balance. It is used. So we do have a limited number of customers that use this, but it's not really great. All right. But it's another tool. It's called the pressure wave method. And for non-metallic water pipes that you otherwise have no way of locating, this is another tool that may be able to help you find that pipe. Okay. All right. So what else is there to locate non-metallic underground utilities? Well, there's such a thing as electronic markers and electronic marker locators. These electronic markers, and you here, and on this slide, you see, I show you 3 locators that locate electronic markers. The one on the left is a standalone device made by a company called Tempo. The one at the bottom is a standalone marker locator device made by a company called Rycom. The one on the right is a combination pipe and cable locator, right, for locating metallic lines, with a fold-down antenna, whose purpose is to locate electronic markers. So the one on the right is a combination pipe and cable locator and electronic marker locator. So you can locate both metallic lines and electronic markers. Now, what are these electronic markers? The balls that you see in the center are electronic markers. The pegs that you see on the lower left of the image are also electronic markers. Electronic markers, if you were able to open one up, all they have inside is a coil with many rounds of thin copper wire and a resistor and a capacitor. They have no battery. They have no maintenance. These things will last for decades underground, and they're made to be placed underground. Very reliable. What they do is that coil is actually tuned to a particular frequency. And these frequencies are, let me go back, these frequencies correspond to the color coding for the device. There's a frequency for green, which corresponds to sewer. There's a frequency for yellow, which corresponds to gas, one for red, power, blue for water, etc. These frequencies are standardized. Every manufacturer adheres to the same color coding and to the same frequency. So those frequencies are standardized for each particular color. So when you need to locate a sewer, for example, a sewer marker, you're going to tell your receiver to go to the sewer marker frequency. You don't need to know what the number for the frequency is. All you need to know is, okay, I'm locating sewer, I'm locating gas, and then your receiver knows which frequency to switch to. Once you do that, as your receiver starts to become near that buried marker, needless to say, you need to have buried a marker along the path of your pipe or in the spot that you need to come back to in the future. Let's say if you're a water company and you have a water leak, you repair the water leak Some water companies, what are doing is they, when they repair a water leak, they drop a blue marker because they know that's a weak point. It's a weak spot. It's a weak point in the pipe. So they may have to come back to that point in the future. Is that if there's another leak in the vicinity, that is a suspect point. So what they do is they drop a blue marker. These markers are relatively inexpensive. We're talking about $13, $10. So $10 for the peg, 13 for the balls. I mean, yeah, it is 13 or $10, but you're not going to go broke. But if you ever need to go back to that spot in the future, electronic markers are a great solution. You put them in. If you need to come back to that spot, you will come back exactly to where you buried it. The range is ranges from 1 foot for the little peg markers to about 3 feet for the ball markers. And I am holding one here in my hand right now. Now, like I said before, these markers inside have coils, all right? That coil is tuned to the particular frequency that corresponds to the color coding, and your receiver has that frequency built in. And then when your receiver happens to pass near the vicinity of where you buried the marker wakes up. All of a sudden wakes up because that coil that it has inside is tuned to that particular frequency. It wakes up, it beams the radio frequency back up, and now the detector from the surface can start to receive a signal to tell you, hey, I am in the vicinity of that buried marker. All you need to do next is just to follow the signal and it'll guide you to where you buried it. Very accurately and without wasting much time, you can get back to where you buried that marker. These are used, like I said before, to mark spots on the ground that you may need to come back to in the future. These spots could be splice boxes, splices, non-metallic lines, valves, anywhere that you might have to come back to in the future, water, repair joints, etc. Okay, inexpensive. As long as you put them in the ground, 10, 20 years from now, 15, 25 years from now, you'll be able to come back to and locate that spot. Okay, these are electronic markers, relatively inexpensive devices, very handy. What else is there to locate non-metallic utilities? Well, you have ground penetrating radar, which is going to be the last item on our call today. Ground penetrating radar has the ability to locate really both metallic and non-metallic lines. And it's a complement to regular pipe and cable locators and to the other tools that we covered here today. Basically, the way ground penetrating radar works is relatively simple. For those of you that are familiar with fish finders, they work similarly. You're sending a signal down, and if there's anything along the path of that signal, some of the signal would bounce back, will reflect back to the GPR. That's how the GPR can tell first that there's something in the ground, or in this case, in the water, that is different from the water. And then it can tell you, okay, if there is something different, such as a buried utility, how deep is that utility? So GPR works somewhat similar to a fish finder, okay? They work with radio frequencies, so we're still talking radio frequencies. This is not radioactive or nothing that is dangerous. It is very low power radio frequency, and it sends a signal out and looks for the bounce back. Now, what I'm going to show you now is, okay, what do you see on the display of a GPR? And this is a typical display that I have here of a GPR. On the left, the vertical column tells you depth. This is depth in feet. So in this screen, we're going from 2 feet to 12 feet. And on the top, along the top, this is the distance traveled in feet. So as you push your GPR, your signal starts to build. And as you can see, as you push it, you're starting to see signal. And the typical response you're looking for is called a hyperbola. And you see here 3 hyperbolas on this image. A hyperbola indicates the presence of an object that is different from the soil around it. Okay. Now, so that could be, for example, a water mains, such as the image that I'm showing you here. Okay. Those three hyperbolas show a water main. Now, this is the same water main shown along multiple passes. So the person that was pushing the cart went in one direction, and you want to go across the target that you're detecting. So you go, you do one pass, you move 2 or 3 feet to the side, repeat the pass coming back, and go over the water mains, a second time, go past it, turn around, go back. So you see 3 responses like are shown on this slide. They are at about the same depth, which happens to be about 7 feet. And they have the same shape. So that is a strong indication that the GPR is detecting a buried object, in this case, a buried utility. In this particular slide, you see great image. The soil is very receptive to the transmission of a radio frequency. There are soils that are not receptive, and you bring out the GPR in those soils, such as heavy compacted clay, and your signal is not able to penetrate the ground. So you don't get any information. It is sometimes it's useless. Some other times it's very handy to have. Now, so how do I know these are 3 water mains? I don't. You don't. So GPR is a complement to your to what you know, to what you're trying to do. Okay, so you know water mains is probably, or the gas mains is probably going to be going along a road. So you're going to go across that road looking for signals of this shape. You know, you have an idea of your utility you're looking for, approximately at what depth it will be. Water mains here in the Northeast could be anywhere from 4 to 6 feet, 7 feet. You might have a 3.5 feet, maybe a service line going to somebody's home. Not very usually, especially as you go more towards the north. Now, what about what if there's a rock? What if there's an abandoned line? Well, you don't know. If it's a rock, you will pick it up right away because you do one pass, you see a hit, okay, you see a hyperbola, you move 2 or 3 feet to the side, repeat the pass, it's no longer there. You go in the other direction, repeat the pass, it's no longer there. So it's a single point. That's not what you're looking for. You're looking for lines. So a line has to be repeatable. You have to see it here. If you move 3 feet, 4 feet, you have to see it again. Move another 4 or 5 feet, you have to see it again. And all those spots, they need to form a line. Okay, so if that happens, if you see about the same depth, same shape, and they form a line, then okay, that's a line. What is the line? How big is the line? You can't tell. All you can tell is there's a line there. Now look at this slide. Okay, here you see very clearly 5 hyperbolas. These were this slide, this profile was taken going back and forth. So you see 1 happens to be water mains, 2, okay, about the same shape, about the same depth, and you see it again here, and again here, and again here. So you see it 5 times. In this particular case, they did form a line. So this was the line we were looking for. Depth happens to be about 4.5 feet. Yeah, makes sense for the water line. But on closer observation, look at this. So you have a big hyperbola here on the left. And if you look closely right under, there happens to be another hyperbola slightly offset. And if you, again, watch closely, you see it again, and you see it again, very faint here, and you see it again, and you see it again. Well, there happen to be 2 water mains, slightly offset, and one below the other. Okay, so this was a very receptive soil, happened to be on the Jersey Shore or near the Jersey Shore, where the soil is sandy, it is not very conductive, and it is great for GPR. Okay, now look at this image on the bottom right. Okay, it is not exactly a hyperbola, it is like a flattened hyperbola. Well, this corresponds to the structure that you see on the left. As you go perpendicular to those ducts, okay, so let's say you're moving from left to right, you're moving from the excavator away from the excavator across those ducts. This is the type of response you're going to get. It is not exactly a hyperbola, but it is not exactly a flat object either. So different objects underground. And again, you need to be sort of a detective when you're using a GPR to interpret what the device is telling you. The device is dumb, it doesn't know. So you need to try to make sense out of what the device tells you. With that, ladies and gentlemen, that is the end of this presentation about locating non-metallic underground utilities. If you have any questions, I have some time, Jim and I, to try to answer your question. You can either raise your hand or pose your questions on the chat, if you would, please.
And remember, you can raise your hand, quote unquote, at the bottom of the chat function there. If you go to the bottom of the screen, you hit chat, there should be a button at the bottom right. It says chat. Other people have also said that it was in the reactions area as well. So either type that into the chat bar, or you can just raise your hand and I'll see that hand come up and we'll call on you there. So.
Thank you much for bearing with me today.
That was a good presentation, Gus, and hopefully that gives everybody an understanding of what the options are out there. We do have a question from eDoors. Do you guys do GPR locating? No, we are an equipment provider. We don't do service, but we can certainly, if you email me at training@eastcomassociates.com, we can recommend a couple of people to you in your area, depending on where you are. So Bob, thank you very much. Appreciate the feedback. Any other questions?
Bit of an advert here as we're waiting for questions to come. I have here the latest RD device, the RD8200. So yeah. I don't know if you guys got your demo units yet, but you'll be getting them. New equipment launched very recently by radio detection to locate metallic lines. So this is not what I covered this morning, but you know, bit of an advert for everybody. Any questions? So do you have equipment for? Oh, good point. Good point. Pressure wave for gas lines. Yes. So there is equipment to locate non-metallic gas lines using a pressure wave, not the one that I described today. Radio detection used to have a device in the 90s that they launched after research that they did together with, I think it was the Northeast Gas Association. No, I'm sorry, the Gas Research Institute. I don't know if they go by that name anymore. The Gas Research Institute and radio detection, they had collaborated in the 90s. They came up with a device called the RD590, okay? The concept is similar to what I described here today for water lines. So you want a pressure wave to travel along the gas. So this device, and there's a French company that makes a variant of it. It is sold in the United States. It's a pricey piece of equipment. You're talking probably in the $10,000 range. And it consists of, think of it crudely, think of it as a speaker, a loudspeaker, all right? that you have to connect to the gas line, and you can connect it, or you obviously needs to be a live gas system. All right, you connect this speaker to the loudspeaker to the gas line, and it emits a sound. Basically, sound is a pressure wave. So it emits a pressure wave that travels along the gas. All right, conceptually similar to the pressure wave system that I described before. And then from the surface, you have a receiving device that is basically a very sensitive microphone, which is tuned to the sound wave that is being injected by the loudspeaker. The loudspeaker is explosion proof because you're dealing with gas. It's a heavy device. I don't remember the pressure limitation on the gas mains. I want to say 50 or 60 pounds, but don't quote me on it. But again, you're inserting a very loud sound. I don't remember the dB, but it's well over 100 dBs, travels along the gas. And from the surface, you have a sonic device that allows you to locate where that sound is traveling, okay? Because that sound makes the pipe vibrate, and the ground around the pipe will carry the sound. And you, from the surface, have a probe that you put on the ground and just to listen for that sound. I've used it. Again, this was many years ago. I know there's a company that does it, that sells the equipment. It is pricey. We just happen not to sell it, but it's a good point. Yes, there is such a device.
Here's a question for you from A. Arnold. Is there a minimum pipe size that GPR is recommended for using to locate?
Okay, so that's a very good question as well. There's a rule of thumb for GPR. Okay, it's a crude rule of thumb, but they say that you can locate 1 inch per foot. Okay, again, 1 inch per foot. So a 10-inch pipe, 10 feet deep. A copper service, a water service, let's call it a 1-inch copper service. Normally in the Northeast, going to be 4 to 6 feet deep. It's going to be hard to pick up at that depth, being a 1-inch copper service, or if it's a 3/4 inch, even worse. Now, keep in mind with GPR, the following happens. GPR locates disturbances underground. The pipe is, or a cable, a buried cable is certainly a disturbance, but how that cable or pipe was installed may also be a disturbance. Sometimes you are not able to see the pipe, but you are able to see the fact that somebody dug a trench to put that pipe. And perhaps when filling back the trench, they used some material a little bit different. So your GPR may not be able to see the pipe itself, but you may see that there's something different, okay? So hope that answers your question.
Another question here, Gus. What is the price ranges for GPR equipment in general?
So GPR ranges roughly from, so GPR for utility locating, because GPR is also used for geophysical applications. Not our case. For utility locating, GPR is going to range from $11,000 to about $25,000, $26,000. What is the difference between an 11 and a 26? Well, the difference is an 11,000, say between 11 and 15,000 is going to give you a GPR to mark. A lot of our customers, all they need to know is, where is my utility? I want to put a mark on the ground, done, I'm out of there. A basic GPR is going to allow you to do that. If you're an engineering company, or you need to create a report of what you do, then what you want to do is not only find where that utility is, you need to document that as well. So a more expensive GPR will have the capability to extract that information out of the GPR, put it on some PC software to do further manipulation in the office, and to create reports, to create deliverables. You can, a more expensive GPR will also allow you to hook up your GPR to an external GPS receiver, okay, to get accurate coordinates of what you see on the GPR's display. So that if you see a water pipe, or if you see that you're following a duck bank, you will have GPS, very accurate GPS coordinates associated with those images, so that at the end of the day, you can send that information to somebody back in the office, or you yourself can send that information to your customer as a deliverable, for example, as a Google Earth map, or as some other GIS software compatible file that somebody else can use. So that is the difference between one and the other.
Another question here for you, Gus, from Rick Roll. Can you use the RD7000 to energize the PurePoint camera like shown in the presentation?
Yes, so the 7000 is a receiver, okay? So to energize the PurePoint camera, what you need is a transmitter, but really any transmitter that you have, any brand of transmitter, will be able to inject a signal that will travel along those wires that are inside the camera cable, okay? And then you can use that as a detectable rod. So you inject the signal with the transmitter, grab the receiver, go out and locate it. Talking specifically about the PurePoint camera, the RD7000 receiver does have the frequency that the PurePoint camera in turn has, which is 512 hertz. So you can locate with a 7000 receiver, you are able to locate the camera. One caveat that applies to the radio detection receivers in particular: radio detection receivers have the ability to configure different modes of operation. When you locate a camera head, you need to be in the 512 hertz sound mode, okay? If any of you have a radio detection receiver and want to confirm that you have the sound mode on, you scroll through the different frequencies on the receiver, and what you want to see is, let me see if I can show you to you guys here. I don't know if you can all see here on the bottom right, it says 512, but here on the right, you see an icon that shows a line with a bunch of circles around it. That is the line mode. You want to be in the 512 sound mode. I don't have any sound mode here. Let me just quickly, if you bear with me, I'll show you what we need to do here. Okay, let me scroll again. All right, I'll go to 512 and you will see. So that is a sound. I know if you can see it on the top right, 512 hertz sound. You want to have that mode activated. Let me go back. That is 512 line. This is 512 sound, okay? If you don't have that mode activated, it is very easy to do. We can show you, give us a call, and we'll show you how to enable the 512 hertz sound mode. Very easy to do. Another question here, I'm a little confused on, from Kevin Burdett. How frequently are the marker balls utilized on Delmarva? I don't have, I can't really speak for Delmarva. I don't know that you use marker balls. I don't, honestly, I don't know. Unfortunately, Jim Verga would be the one to have an answer for that, but he's
Hey,
not on the call
Gus.
today. Hey, Mark.
Hey, I cover some of Maryland and the Eastern Shore over there, and I've got a couple of utilities that are using the marker balls. They hold up real well. Some were for the gas company, some were for power, and some of the other ones were for water and sewer.
All right.
Okay.
Any other questions? If you didn't get to ask your question here, you can always reach us. I think that my
Yeah, I put that in the chat there. You can email us at training@eastcomassociates.com, and we'll forward that to your area representative to be able to reach out to you. to help you with any needs that you have. All right, well, if there's no other questions, we really appreciate everybody joining today.
Thank you.
Very good job, Gus. Round of applause. Yes.
Thank you.
Our next class, our next like big open class, we have a class this this Thursday on the pipeline current mapper. For those of you in the pipeline industry who are involved in your cathodic protection services, we're doing an overview of that pipeline current mapper. If you're interested in that, again, email me. Next week, we're going to be doing the basics of utilizing metal detectors for underground utility locating. And also next week, I believe, is GPR. Is that correct? I should know this. I set them up. Hold on. Yes, the 19th is metal detecting. I'm sorry, the 21st, leak detection with Eric Denslow is the 21st. So waterline leak detection. We're going to be doing that on the 21st. Then January 26th, we are going to be doing an Eastcom equipment Q&A. So anybody who has any equipment and has some questions on theirs, we're going to have an open meeting at 2 o'clock for anybody to just pop on and answer any questions. Then we go into February, and we're going to have utility mapping options with GPS. That's with our other rep, Jeremy Somerville, out of Western Pennsylvania. So utility mapping options that are out there for everyone. And then February 4th is GPR. So we'll be covering GPR more in depth. We're actually going to have a guest speaker for that one, Ken Wright. And then February 9th, we're going to be going through crawler camera and pushrod camera operations. So those who utilize cameras, we're going to be demonstrating some of the functionality that's out there for camera options. Beyond that, when we get into February, we are going to be doing a more in-depth presentation on our locate theory overview. It's actually a 3-part series, 3-hour-long segments broken up over 3 days. Be on the lookout for the invites on that. Those are going to be bigger classes. They really break down the nuts and bolts of locating. They are a virtual version of our all-day class that we normally do. So if anybody's ever attended that full-day class that we do, we're trying to do it virtually this year. So be on the lookout for that invite as well. That's going to be coming very soon. All right. Well, again, reach out to us with any questions. training@eastcomassociates.com. Thank you again, everyone, for joining today. And we look forward to seeing you next time around.
Thank you all.
All right.
You guys have a good day. Good job, Gus.
Thank you, Mark.